Hello everyone. In convolutional neural network, the backward propagation is used to update the parameters in the given network. Here, the parameters are weights and biases. The weights are given through the filters of the given kernel, right? So here, these weights will be used in the fully connected layer. Bias will be used for all the neurons given in the hidden layer network and fully connected layer, and filters will be used for extracting the features from the given input. So these all things are called as parameters in convolutional neural network. All the values initially initialized with random number of values. Then after forward propagation, we will get the output here in the output layer. So if we are having error in the output layer, then we have to update the parameters to reduce the error in the given network through the backward propagation. So here the backward propagation is using gradient descent technique to optimize the given model by reducing the error or cost. Here, consider the curve for the loss function where we are having the parameter a. So here we are having the curve, the converging curve. So here we are having the parameter a in it, and this is indicating with random initialization value. Here the uh, we get value is a2. So this is the a2 we are having. So it is clear from the given figure which is the minimum value of loss which is available at a1, it not in the a2. So here the a2 is having the error more, and here which is having minimum error. So this y axis is minimum indicating the error. So this is indicating the parameter a. So here the position, this one is having minimum error close to the 0, but here we are having more than the 0. So now the gradient descent is trying to find the parameter value at which the loss is minimum, that means error is minimum. So from the figure we need to update the value a2 which is bringing to the closer to the a. So here we are having the slope like this. So we are having the slope like this. So we have to bring this towards into the a2. Then to decide the direction of movement of that a2 towards a1, we have to increase or decrease the value of this parameter by using the gradient or slope of the given parameter a2. So we have to find out the slope here. Then based upon that we have to decrease or increase the parameter value to bring that towards a1, which is close to the error 0. Okay, so based upon this value of the gradient we can determine the updated parameter values. So here when slope is negative, then we have to increase the parameter value in the given picture, and when your slope is positive, then we have to decrease the parameter value by small amount. Here as I told you, the parameter in the sense we are having the weight parameter in the fully connected layer, then kernel value, filter values in the given convolution layer, and we are having the bias for each and every neurons. Then here the grade generic equation for updating the parameter is new parameter equal to old parameter value minus learning rate into gradient of the given parameter. So the learning rate is here used to control the amount of change which is being made into the old value. So here the old value is there, then we are applying the delta rule here to update the parameter value by finding gradient for each and every parameter. Then we will get the new parameter. Here the slope or gradient is determining the direction of new values. That means either that parameter value is decreasing or increasing. So we need to find the gradients to change the error. That means to reduce the error with respect to parameters which are available in the network by updating this parameter by using the gradient descent technique. in convolutional neural network we will have fully connected layer at the end, then we will have the classifier here. The before that we are having some convolutional layers, and here we will have the input. Okay, so here this is the convolution layer, this is a fully connected layer, then we will have the output layer which is giving you the classification output. So here which is given briefly, the input is given into the convolution layer. The convolution layer is having sigmoid activation function. Then another one here we are having the output layer. Here we are having the sigmoid activation function. So after getting the output, we are going to calculate the error. So in the fully connected layer, when you are applying the backward propagation, which is having two types of parameters, one is the weight matrix and bias vectors. So here the weight matrix will be indicated with the W, bias vector will be indicated with the B. So based upon that we have to update this parameter values here. You look at that, here we are having the weight values, and here we are having the bias values. So here when you are calculating the change in error with respect to W, so here the error is indicated with the E. So we are going to check the update the parameter value W, right, based upon the error. So here error is not directly depending on only the weight matrix. Okay, so this weight matrix which is also depending on other bias values and also filter values. So we have to use the chain rule, the error divided by with respect to parameters W1, W2, W3, etc., Wn. So that is the capital W here. So now which is equal to the first we have to take this error. Here error is there, then dou E divided by this output of the sigmoid function. So dou E divided by dou O. So delta rule we are applying here, dou E divided by dou O, and here then we are going back. So here the output, with respect to output, we are having the G2. So dou O divided by dou G2. Then we are having the parameters here W transpose. So dou G2 with divided by dou W. Okay, so here we are going to use the terminologies dou E divided by dou O, this one and this one. So we have to identify the values for these three terminologies. Now we have to identify with respect to output uh, this term first. So when you are taking this term first, here I am using the loss function here, the least square error function 1 by 2 into actual output minus predicted output whole square. When you are applying this partial differentiation with respect to output, so here the output is indicated, predicted output is indicated with O, right? So that's what we are saying. So dou E divided by dou O equal to, so when you are applying this, it will come 2 into already 1 by 2 is here, 2 into here you will get y minus O, right, into here we will get minus 1, right? So that's what we are getting when you're taking 1 by 2 into 1 by 2. So minus of y minus O. So that's what we are getting the term here. Then here we are having one more parameter G2, right? So now we found this one, so we have to found this one, dou O divided by dou G2. So here G2 is value the sigmoid of this function. So 1 divided by 1 plus e power minus G2. When you are applying the partial differentiation, you will get this terminology. So this is 1 by 1 1 plus e power minus G2. So output formula, then in of 1 minus output. So this is the value. So next one is here this terminology you have to find out. So this is change with respect to the parameters W. So when you are applying this G2 function is here we are having this one. So when you are applying the change with respect to W, then you will get this terminology A1, this will become 0. okay, so this will become 1, so you are getting the a1, right? So then now we found all three terminologies here. After that you are substituting the values for all these terminologies, so finally you are getting dou e divided by dou w. Then the formula to update the parameters, any number of parameters, I have given the capital W in the sense w1, w2, etc., wn. So any w, so new w value equal to old w value minus learning rate alpha divided by this value we found until here by using the delta rule, right? Now we have to come back to this one, right? So here again we are having the bias values, okay? For each neuron we are having the bias values, this one. So when you are applying this term, so we know already these two terms. Here we are having only this term, so we have to find out this term. So when you are applying this dou g2, so g2 is here, the formula is this one, so you will get the first term will become 0, and here the first term is w transpose into a1, so this will become 0 plus b, so it will become 1. So that's what this one is given here. So when you are substituting the values, you will get this term is this one, and this term is this one, and this one is 1, okay? So when you are updating the bias values, you are getting new bias equal to old bias value minus alpha is the learning rate, then dou e divided by dou b. Now we have completed until the fully connected layer. Still we are having the convolution layer, so that we will see now. So here we have to move into the convolution layer into here, right? So this can be done again by using the formula. Same thing here, we have to complete the parameters. Here the filter we are going to use in the convolution, the input will have the image, right? So on the image we will apply some filter values, okay? So w1, w2, w3, w4, like that kernel values, that's what we are using. This one is indicated with filter, right? This one input is indicated with x. That's what here we are using z1 equal to x into f. So all the parameters here we are using in the filter, we are taking as a f. So the g1 is x into f, the dot product of f. Then we are going to apply the sigmoid value for each and every g1 value, so sigmoid of g1. So when you are applying the chain rule for finding the parameters, so here we have to update the filter value parameters. That's what we are going to use, the filter value parameters dou e, okay? We are with respect to filter values, error, the partial differentiation with respect to f. So here when you are applying the chain rule, so error divided by dou o, then the dou o divided by dou g2, then this dou g2 divided by dou a1, this one, then dou a1 divided by dou g1, then dou g1 is having all filter values, so dou g1 divided by dou f. So that's what given here. So we have to identify the values for all this. Already we found in the previous slides these values until here, so we have to found these three terminologies. Now dou g2 with respect to dou a1, so here when you are applying the partial differentiation with for this equation, you will get this one is the output for dou g2 by dou a1. Then next terminology dou a1 divided by dou g1. So when you are applying that formula, I mean partial differentiation over this sigmoid of g1 equal to 1 divided by 1 plus e power minus g1. So when you are applying this, so this is indicated with a1, you will get this value. That means sigmoid of g1 into 1 minus sigmoid of g1. So here sigmoid of g1 is indicated with a1, so a1 into here 1 minus a1, okay? That's what we are getting. So this is also calculated. Finally we have to calculate the dou g1 divided by dou f, that is the filter values we have to update. Filter will have so many parameters based upon the 3 by 3 or 2 by 2, so we have to update all the parameters. So here we are having the equation g1 equal to x1 x into f, so we have to find out this one. So when you are applying the partial differentiation, you will get the capital X. So X is also again you are having the matrix any number of values, so x1 x2 x3 etc xn. Okay, then you have to substitute all the error values here with respect to all the parameters. The finally you are getting the updated parameter values, updated filter values. Okay, then you have to change all the filter values here. Again you have to apply the forward propagation. Now you will calculate the output. So again if you are getting the error, then you have to go for one more back propagation. So we have to keep on do that until we are reaching the converging point. That means converging point is here as per our graph, it has to reach the close to zero value. The error is here to reach the uh, close to zero. So here after reaching the converging point we can stop the process. Finally we will get the curve like this. So initially our error may be here, then when you are updating the parameter values w, bias and filter parameter values, it may be reaching into the close to zero. So this is about the CNN backward propagation. This formula indicates updating the filter values. F new filter value equal to old filter value into learning rate into this chain rule value dou e divided by dou f. Already we have calculated for the dou e divided by dou w and dou b divided by dou w. So all things we have sorry, dou e divided by dou b, right? So we have calculated all the values. So now we have reached the updated value. Then we can again continue the process. Thanks for watching.